In this video, we are going to discuss the cone pulley drive and the back gear drive and see them working. These are commonly found in lathe headstocks and drilling machines. The headstock houses a spindle connected via a speed changing mechanism to an electric motor. A cone pulley is basically a stepped cone. In this arrangement, there are two cone pulleys. The driving cone pulley is coupled directly to a motor, while the other one is driven by a belt. The steps are used as a pulley of a belt pulley system to transmit power. Four different positions of the belt gives four different combinations of pulley diameters, hence four different transmission ratios. So, from the constant motor RPM, we get 4 different RPMs of the driven cone pulley for the 4 positions of the belt. Now, how do you reposition the belt if you need a different RPM? Well, you stop the motor. There's a hand wheel to bring the cone pulleys closer so that the belt becomes loose and you can change the belt position. Now, 4 speed variations are not enough. So we have back gear drives. The driven cone pulley rotates freely over the spindle. A pinion gear P is fixed with it. The spindle gear S is screwed to the spindle and rotates at the same speed as the spindle rotates. There are two gears Q and R on a parallel shaft that can be disengaged. These are called the back gears. For faster speeds, the back gears are disengaged. The spindle gear is directly connected to the cone pulley using a pin. So the spindle gear rotates with the same speed as the cone pulley. So does the spindle. For slower speeds, the back gears Q and R are engaged. The pin is removed. Motion is transmitted from the cone pulley to the spindle gear via P, Q and R. Such a gear train is called reverted gear train and the arrangement is back-geared arrangement. Let's take a look at these mechanisms in a drilling machine I found. You can see the belt, a motor and two cone pulleys. Power from the motor is transmitted through the driving cone pulley to the driven cone pulley. There is also a back gear drive here. If you look closer, you can see a pinion gear below the cone pulley and the spindle gear above the cone pulley. These are the back gears Q and R. Right now the back gears are disengaged. You can see the pin that is engaged connecting the spindle gear to the cone pulley. The cone pulley gives us 4 variations in speed. With the back geared arrangement, we get 8 different speeds. 4 faster speeds when the pin is connected and 4 slower speeds when the back gears are engaged.